Okay, looking to do now, we see a flat shape. We've not worked with flat shapes in quite a while, but we want to determine the area of the shaded region. So one of the best ways to calculate this is to not to break it up into individual pieces, because you very well could break this into individual pieces and say find the area of each piece and then go ahead and find the value. However, probably the best way to do this is to think about this as subtractive area. So you started with the area of a large shape and you subtract away the area of the smaller shape. So the area of the larger shape is a base times height, and the smaller area is also a base times height. So the larger area is 6 times 3, and the smaller area is 5 times 2. And so that's 18 minus 10, which gives us a area of 8 centimeters squared. All right, we're going to be using this idea now with volume in addition to being able to use it with flat surfaces. All right, so our aim Kipsters will be able to find volume of composites. Composite figures. Specifically today, figures that are made by subtracting something from it. All right, so when we look at this, we have an insulated box that is shown. It's made from a large cube, and they've hollowed out, or they've taken out, a right rectangular prism with a square base. So we need to calculate the volume of the outer box. Now we're told the outer box is a cube, which is not going to quite be true because we can see that it is 21 centimeters tall, but we are to assume that the base here is 24 centimeters. So let's go ahead and calculate that out. Calculate the volume of the outer box if it is 24 by 24 by 21. So our volume of the outer box would be area of base times height because it is a form of a prism. Go ahead and calculate that on your own. Alright, so the area of our base would be 24 by 24 times a height of 21. Which, when we calculate that out, is going to give me 12,096. So we can see that the area that's cut out of it, this piece here in the middle, where there is not going to be any insulation or water put into it, is going to be a right rectangular prism. So we can see that it sits up in there, and it is the entire height of the entire box. So we need to find the volume of that prism, volume of the inner prism. Go ahead and calculate that on your own. Should have that it's the area of the base times the height. The base is 18 times 18 times the height, which is also 21. So this is going to be, when we calculate that out, will be 6,804, and we never put units on either of these, cubic centimeters. Alright, now describe in words with your team, how would you find the volume of just the insulation, just that part in the middle? How would you find the volume of just this space? So what your team and you should have discussed and written down is that you would subtract the inner and outer volumes. All right, so go ahead and calculate the volume of the insulation. So calculate the volume of that space, that shaded area, on your own. So thinking about this is volume of the outer minus volume of the inner, which, if we come back and look at our numbers, is 12,096 minus 6,804. And when we calculate that, that's going to give us a volume of 5,902. So calculate the volume of the water of the box that it can hold in liters. So remember, we're talking about 1 liter is 1,000 cubic centimeters. So if I wanted to figure out how many liters this is, how would we figure that out? So we've seen this plenty of times before. If 1 liter is 1,000 centimeters, to get it back down, there'd be somewhere between 5 and 6. And we want to do the division. 5,000 divided by, and that's going to give me 5.292 liters. All right, looking here on the other side, we've got a similar problem. We see a similar shape. One thing that I'm going to note about this problem before you get it started is that in order to do some of the work here, we're going to want to think about this in cubic inches. So in order to do that, I'm going to go ahead and convert all of these feet to inches. So I'm going to convert this one to 144 inches. I'm going to convert this 9 to 9 times 12 would be 108 inches. And this 2.5 feet, well, that'd be 12 plus 12 plus 6, which would be 30 inches. And the reason why I'm doing that is I want to have all of my units here in inches, and that makes it so we have cubic inches. We're using all the same units. You can't mix units. So you either had to pick feet or inches, and we're going to see later in the problem that there are several other parts that ask us to do things in cubic inches. All right, so what are the interior dimensions of the planter if the thickness of the planter's walls is equal to the length of the brick? So basically we're seeing here in the picture that the length of the brick is 6 inches, so the thickness of the wall is 6 inches. So I'm going to draw a top view of this, of what this would look like from the top view, and I want to label these inner dimensions. We know this is 144 by 108 on the outside, and we want to know what it would be on the inside. So thinking about that, the inside, this inner dimension is if we are taking 6 inches off from this side and 6 inches off from this side, which means we're going to have a total length from that interior. We're going to have subtracted 12, which would give us 136. And same thing here from the bottom and from the bottom. So think about that. What is that going to give us as our height of our interior? Should be 108 minus 12, which is going to give me 96. All right, so what is the volume of the bricks that form the planter? So we're looking for just the shaded part here of our picture. And in order to do that, think about how you would do that. Name one way that you would do that. There are actually two methods here. One would be to think about this as a prism and actually find the area of the shaded region of the flat figure and then multiply by the height, since it is in a lot of ways exactly like a prism. Or the other way would be to find the outer volume and subtract the inner volume. Because we've talked about that already today, why don't you go ahead and solve it that way. Find the volume of what would be the outer box that we started with, and then subtract away the inner box. So if we do it this way, the volume of the outer is equal to the area of the base times the height. The volume of the inner is equal to the area of the base times the height. The outer is 136 by 108. And the height, if we go back to our original drawing here, we can see the height of that prism was 30 cubic centimeter, or 30 inches. For the inner one, for the outer one, this is 144 by 108. Sorry, I got a little carried away there. For the inner one, it is 136 by 96 is what was taken out, and it has the same height of 30. So we want to plug that in and do that work on our calculator. And for this one, I get 466,560. And for the second one, I get 391,680. All right, so again, what am I needing to do with these two volumes in order to find the volume of just the bricks, just that shaded outside region? Should have said that you need to subtract them. So volume outer minus volume inner would be 466,560 minus 391,680. And when we calculate that out, we should get 74,880 cubic inches, or inches cube. All right, so it tells me that we're going to fill the planter 3/4 full of soil. How much soil would we need to purchase? All right, so the soil goes only on the inside. So the soil only goes on the inside. So the soil is going to be a fraction of the inner area, all right? The inner volume. So we're looking for 3/4 of that inner volume, and we want to know what the height would be. Well, the height's just going to be 3/4 of the height of the planter. So we should be able to calculate both of those as a fraction of a whole. So 3/4 of the inner volume and 3/4 of the height. Calculate each of those to determine the volume of the soil and the height that the soil will reach. All right, so if we calculate the volume, 3/4 of the 3,000, 3/4 of the inner volume with 3/4 of 391,680. We could treat that as a fraction over 1, or we could think about 3/4 as 0.75. Same thing with the height. Our height was 30 inches, so 3/4 of 30 inches. And when we calculate that, we'll get the volume of the soil as 293,760 cubic inches, or inches cubed. And 3/4 of the height, so the height of our soil, is equal to 3/4 of 30, which would be 22.5 inches. All right, so that's kind of the major piece here. Now we're going to move on to some other ideas. It says each brick used in this project costs 82 cents. The company has a delivery charge of $15 per whole ton over 4,000 pounds. How much would your school pay for the bricks, including the delivery? So this means that we actually need to find out how many bricks there are going to be. So here's how we're going to do that. We know the total volume of the bricks. The volume of the bricks is equal to what we found out down here was 4,000 666, 300 or 500. Sorry, it was 74,880. The volume of the bricks, 74,880 cubic inches. So when we think about this, if we divide that by the volume of each brick, that's going to tell me how many bricks we need. So we need to find the volume of each brick. Well, we know the dimensions of each brick are 6 inches by 3.5 inches by 2 inches high. So the volume of each brick is the area of the base times the height. Well, that's 6 times 3.5 times 2 is the height. When we calculate that out, we get 42 cubic inches. So divide this by our 42 cubic inches for each of the bricks, and that's going to tell us approximately how many bricks we're going to need. And so I calculate this out as 1,782.85. So that means I'm going to need almost 1,783 bricks. Alright, coming down here, it tells us that each brick costs 82 cents and weighs 4.5 pounds. The company charges a delivery fee of $15 per whole ton, over 4,000 pounds. So how much will your school pay for the bricks, including the delivery? So in order to find out how much the delivery charge is, we need to figure out how many pounds they weigh, because if it weighs more than 4,000 pounds, then we're going to have to pay $15 for every ton over that weight. So let's start by finding the weight. How would we find the weight? We know how many bricks, we know how many each weighs. So go ahead and find our total weight. So our total weight should be 4.5 pounds times the 1,783 bricks. And that should give me that there are 8,023.5 pounds of bricks. So when we think about that, how many sets of tons do we have over that? So minus the 4,000 that we get for free leaves me with 4,000 tons, or 4,000 pounds, and 23.5. So whole tons over, so we are 2 whole tons over, so that means we're going to end up paying $15 twice. So whatever we're going to get, we're going to add $30 to it. Now we want to pay for the price of the bricks as well. Those are 82 cents. So our cost will be the 82 cents times the number of bricks plus the $30 of extra delivery costs. So go ahead and calculate that out. We'll get that our cost is equal to $1,492.06. Dollars. Oops. Try that again. Dollars. Alright. Tells me a cubic foot of topsoil weighs between 75 and 100 pounds. How much will the soil in the planter weigh? So a cubic foot, on your paper this actually tells you how many cubic inches. So in yours it tells you 1,728 cubic inches. If topsoil weighs between 75 and 100 pounds, how much will the soil in the planter weigh? So we need to figure out how many sets of 1,728 cubic inches we have. So our soil, our volume of our soil here was this number over here. So I have the 293,760 divided by 1,728. And then whatever that is, I need to figure out what it's between over here. So I'm going to start by calculating how many sets of this 1,728 we have. When I do that, I actually get exactly 170. So it's somewhere between 170 times 75 and 170 times 100. So we're going to figure this out. It's going to be between 170 times 75 and 170 times 100. So that's going to be somewhere between 12,750 and 17,000 pounds. If the topsoil costs 0.88 cents per cubic foot, calculate the total cost of the materials that will be used to construct the planter. So again, this cubic foot is the same thing as these 1,728s, which we know there are 170 of these cubic feet. So that's 170. But it also wants the total cost of the planter material. So we already know it's $1,492.06 for the bricks and the brick delivery. But plus we also need 88 cents times the 170 of these cubic feet that we have calculated over here. So once we calculate that out, the 88 cents times the 170 tells us the soil will cost us $149.60. And if we add that to the cost of the bricks, we'll get a total of $1,641.66. Right, so that's a relatively long problem, lots of different steps, but really they're just one step at a time. We know how to do each of the individual pieces there in order to do that. All right, so flip on over to your alone time and get your work done there.